Okay, so I'm going to show you how to make a perpendicular bisector, which can be quite handy. And there's one super easy tool in GeoGebra that does it automatically. It's called Perpendicular Bisector, and it's under that section with perpendicular parallel lines. And voila, there you go, a perpendicular bisector. But for thousands of years, we didn't have that tool. So what do? So I'm going to make another segment here on the side. I'm not going to be too worried if it's the same size as that one or not. And we're going to make a perpendicular bisector for this tool. So how could we find a way to get a line that cuts the segment in half and is perpendicular? Well, what I'm going to do is, first of all, I'm going to just create a circle. So I'm not really using the compass. I'm just putting a circle here at point C. And I'm picking some point E. It can be past D, it can be anywhere, and I'm just going to just set it. Okay. I'm going to do the same circle on the other end. So if it's going to be the same circle, I have to use the compass tool. C to E, so I click on C, click on E, then move this around until it's centered on D. So this left circle is the same size as the right circle. It's not very helpful to me right now. I'm going to click on the move so I can adjust E until these two circles intersect. Once I can get these two circles to intersect, and not just, well, if I could get them to intersect in just one point, I'm pretty sure the midpoint's right there. So I could say, hey, where do these two circles intersect? I'm going to click on the intersect tool, and come click on the first circle, and then the second circle. It looks like they really don't intersect yet. Let me go a little bit further. Oh, look, 2 points suddenly appeared. Point F, and it looks like point G. All right, so that's where the two circles intersect. So what's so interesting? I'm going to move this point E out of the way. Well, if I were to make a segment and connect from C to F and from F to D, right? Which one's longer, CF or DF? Hopefully, you'll figure out they're the same. Why are they the same? Well, the circles are the same, and you're going from the center to the edge on both circles. Same thing down here. So I'm making these isosceles triangles. And even if I make E bigger, you could say, well, it's because of where you have E set. As long as E goes more than halfway, as long as your radius is more than halfway across the segment, I'm going to have that shape there with the isosceles triangle on top and the isosceles triangle on bottom. Now I'm going to go ahead and connect it, and this time I'm going to do a line instead of just a segment. Clicked on F, then I come and click on G. Now, why does that segment or line, either one, have to go through the midpoint here? Well, let's take a look. I know that there's another isosceles triangle. See, from here and these two, which one's bigger? They're the same, right? And this segment is congruent. So I can say this triangle is congruent to this triangle, which means this point. Let me go ahead and name that intersection. I'm going to click on the intersect tool. So CH has to be the same as HD, since the triangle FCG is congruent to the triangle FDG. So I know that these two are congruent, and H has to be the midpoint. But I also know that now that I know these two are the same, let's just look at the top triangle. So I'm going to hide the bottom triangle. I'm clicking on the Move tool, right-click here, so I don't show that. Right-click here, so I don't show it. I just figured out these two are the same. These two are the same. And this one is the same as itself. So this left triangle is congruent to the right triangle. When I have this line going to the midpoint on an isosceles triangle, if you recall, it has to be the altitude. Why? Well, these two angles have to be the same, and they add up to 180. Well, the only two angles that add up to 180 that are the same are two 90-degree angles. So not only is this a bisector of the segment, it's also perpendicular to the segment. And for thousands of years, we have been using circles to create perpendicular lines or segments that cut another segment in half.